A four-term sequence is formed by adding each term of a four-term arithmetic sequence of positive integers to the corresponding term of a four-term geometric sequence of positive integers. The first three terms of the result of four-term sequence are 57, 60, and 91. What is the fourth term of this sequence? Okay, so let the terms be a plus k, a plus 2k for the arithmetic sequence, and br square for the geometric sequence. So if you add these term by term, we get these sums: 57, 60, and 91. Okay, we have four unknowns, a, b, k, r, only three equations, right? With these sums. Looks like we have more unknowns than the equations, so we expect lots of solutions to this system. But the key here is to observe that the terms are positive integers for both of these sequences. So that should limit the cases. So how do we use that? Going from the first and second terms, the gaps for the arithmetic sequence are always the same, right? But for the sums, the first gap is 3. For the second one, it's 31, right? So it's not the same. It increased by 28. And that should be because of this. The gaps in the geometric sequence are not the same, right? So the second gap here is 28 more than the first gap. So we can get an equation just in terms of the variables of the geometric sequence. So what does this? If I combine everything on the left side, all the unknowns, get b times r squared minus 2r plus 1 equals 28. And that I can factor this, and that gives me a nice expression in b and r. And I know that b is a positive integer. And so the solutions for this can be, let's see, this I can factor this as 1 times 28, or 28 times 1, or I can factor this as 7 times 4 is a square, right? So let's check those possibilities. If b is 28, r minus 1 squared is 1, r is 2. If b is 7, r minus 1 squared is 4, so r is 3 here. So what do we get now? Well, there's this extra possibility that r doesn't have to be exactly an integer, right? R could be a fraction, and it may still turn out that br squared might turn out to be integers. But these are the most obvious cases, so let's look for these. And if we can get a solution, then that will be the answer. If we if neither of these lead to a solution, then we need to look at the possibility that r might actually be a fraction, not necessarily an integer. But let's look at these first. So let's see. So let's go back to our sequence and write the geometric sequence for these values. So if b is 28 and r is 2, then the first three terms are these. Well, 112 is already past 91, so that would lead to a negative value for the arithmetic sequence, right? So this is the arithmetic sequence term. The third term will be negative, which is not good. So no solution here. And if for the second case, if b is 7 and r is 3, so we triple each time. And for the sums to be 57, 60, and 91, we need the first term of the arithmetic sequence to be 50. The second term should be 39, and the third term should be 28. So these decrease by 11 each time, which is good, and these triple each time, which is also good. So this works. This is a solution. That means this is the intended solution. And let's continue with these sequences. So decrease by 11, 17, triple, 189. So if you add these, we get 206, which is answer E.